Hi everyone. Mic test, mic test. There's something wrong with my tablet right now. Sorry. Let me take a look first. Okay. So I'm using my handphone. My handphone is a bit more laggy. Okay. Okay. Now I can access it. Good. Okay. Hello to everyone. Wendy, Rekha, Elaine, Sandhya, Ferron, Wei, Lai Boon Kwang, Nixis, Polly, Xing Meng Leong, Mei Ling, Melvin, Unicorn, Samuel, Edison, Jessica, Cherry, Adeline, Vinny. Everything, ask your brother to watch instead. Carol, Elaine, Kendrick, Amanda, Xing Mei Leong. Okay. Alright, thanks for being here. Thanks for putting up with the delay. Thank you for your patience. Now, okay, here, welcome to today's Facebook Live, brought to you by Maths Heuristics, happening every Wednesday at 8 PM. So over here, I've just introduced this archives page, because we are getting a lot of questions as to whether the replays are available or not. You can view them all over here. Okay, and this is the page to download the notes. Right, for us, we won't delete the live streams unless something happens to our account. Okay. Alright, so a bit about myself. I'm the curriculum specialist here at Maths Heuristics. I've been working here since 2011. This is my first career, to be honest with you, and been here since then until now. You can do the math on how long that has been. So I also hope that this can continue for a long time. So over here, I've been involved in several projects, one of which is the Maths Heuristics app. So let me show you my proud piece of work. Where is it? Okay, this app allows you to go through the explanation in a step-by-step interactive manner. So you can either view it as a one-shot solution. It's a bit too bright, I don't think you can see it. Or it can be gone through in an interactive manner, whereby the setup, okay, the question has been set up here, then you can go through it step by step, and the thought process will be all laid out for you. Okay, that's one of the projects I was involved in. And also, these ideas are based off the books on the Mastering Heuristics series, one of which is the Spatial Visualization book, written by my mentor, Mr. Sani Tan, who has been an ex-MOE teacher with more than 20 years of teaching experience up to date. So this was written back in 2014. It was printed in 2014. And over here, you can see that the contents of the book, okay, is all laid bare for you to see. and it's written in a way that explains the thought processes of breaking it down. Of course, there is also the one-shot solution and the explanation on how to derive the answers. Now, I emphasize a lot on thought process these days because it is okay. You go into the PSLE trying to memorize every single question that you've practiced. That's not going to work out, because at the PSLE level, they would have questions that you really have to understand the whole logic and the gist of it in order to solve and break it down, synthesize the information, and evaluate for the information. Okay, now over here, this is the contents of the book, and today in particular we will be emphasizing on the drawing of lines. Alright, okay, let me just take a look. Why the head shaking? Oh, the app. Okay, the head is shaking because we want you to tap on it to proceed, but only after you've read and understood what's going on. Okay, so today I'll be focusing a lot on the drawing of lights. You can see that in this one technique alone, I can explain it for about 45 minutes. Okay, so here is one question that is quite uncommon, yet it is although it is a 2-mark question, it is a type of question that stumps students when they look at this 8 cm diagonal over here. We are to find the diagonal, we are to find the area of a square whose diagonal is 8 cm. Okay, so over here, there is one important part about geometry that is seldom talked about. Now, when they tell you that a figure is a square, what are the properties that comes along with a square? First of all the sides are equal. This one everybody knows by now. Then the next one is that something that everybody knows but seldom mark out is that all the angles here are right angles. Okay, so why is this important? Because if we do it if we mark out everything, we can see that this will become 45 degrees. This will be an isosceles triangle. So all the angles in a triangle adds up to 180 degrees. So if this is already 90 degrees and this is an isosceles triangle, these two angles has to be equal. These two angles would have to be 180 minus 90 already. Okay, bracket up the thing. Okay, and divide this by 2. We will get 45 degrees over here. So this is an isosceles triangle, and we can do this because the sides are equal. This is 90 degrees. So having said that, let me go through the two ways of doing this. If I were to draw another isosceles triangle here, hang on, I think my thing is lagging. Yeah, it's lagging because I left something open. Okay, should be okay now. So if I were to draw another line over here, because these sides are equal, by that same reasoning, this angle here, these two angles would also be 45 degrees and 45 degrees. And then we can say that this diagonal, this red diagonal over here, has also got to be 8 cm. True? Then once we have this already, you see that inside a square, These two lines will pass through the midpoints and they will dissect each other at this point. Doing this would produce a right angle over here. Okay, then from what we can see, if this is the midpoint of the square, and this length here is 4 cm. This length here must be 4 cm. So to find the area of this square, you want to find out, instead of using these two lengths over here, which you do not know about, okay, we can use this as the base, and if this were to be your base, then this would have to be your perpendicular height. Okay, so then the figure is formed by two copies of half times 8 times 4, and this will give you, okay, wait, for completeness I'm going to write down the units here, and this will give you 32 cm squared. Okay, so this will be your answer for this question. So of course there are parents who are asking me, can I use Pythagoras theorem? The answer is technically yes, you can. You can say that if, let's say, this is A and this is A squared plus A squared, okay, this is for PT, Pythagoras theorem. If you don't understand what is this, don't worry about it. Equals to 8 squared, so 2a squared is equal to 64, a squared is equal to 32, then a is equal to square root of 32. So this is the square root of 32, this is the square root of 32, which when you key in your calculator, you get a decimal, a never-ending decimal, to be exact. Then you're kind of stuck. You don't know how to go along with it. So this is not covered in the primary syllabus. Okay, Pythagoras theorem itself is not covered in the primary syllabus. The student doesn't need to know at this point. Of course, if they know it, they can definitely use it, but I would advise them to fully understand how to manipulate and deal with it first. Okay, PT is not required. But anyway, the other way of doing this is by rearrangement of parts. So I would emphasize on spatial visualization techniques rather than the formal secondary school mathematics that's not taught at the primary level. Okay, to deal with this in the rearrangement of parts point of view, what you want to say is that if we isolate one of these triangles here, we can say that this is 8 cm. And remember about the 45 degrees thing that we found out earlier? What if we are to add on 3 more triangles, 3 more identical triangles? Then this will be 45 degrees, this will be 45 degrees, this will be 45 degrees, 45 degrees. This will be 45 degrees, and this will be 45 degrees. And then you see that all these sides are all 8 cm. And it fits up nicely to give you a square that is 8 cm. So this entire square is formed by 2 such triangles. So all we have to do is we have to take half times 8 times 8 to give you 32 cm squared. Okay, so this is the second method, rearranging, and the first one is by the drawing of lines. Okay, so there's a myriad of ways that this can be done. No, the PT thing, don't worry about it. You cross the bridge when you get there. That's probably like Sec 2 stuff. So don't worry about it. No, I'm not teaching about PT. I'm talking about, like, if your parents want to do that, technically they are correct. But you don't need to know about Pythagoras theorem at this point. Okay, just clear your P6 first. Then you cross that PT bridge when you get there. Okay? That's one idiom that I've been hearing a lot recently. Cross the bridge when you get there. Okay? Alright. You P3 only, yeah? Okay, so if you all understand, please spam the like button. Hang on, let me just reply some people first who are kind of stuck. Okay. Okay. Alright, thank you for your feedback. Let's go to number 2. So if you are wondering why my slides picture is bigger than your printout, the reason is because I want to emphasize on the figure. So for this figure over here, you see that you want to find the area of the shaded part. Okay, a few Facebook lives ago I was talking about the rearrangement of parts as well. Okay, for this particular question, you see that this shape, if you try to do it directly, you're going to have a bad time. You're going to have a hard time doing it directly. Okay? Now remember, the main thing I keep on emphasizing during that lesson was that you want to rearrange in such a way that you can use the known formula to compute for the answer. That's one thing I kept on emphasizing. So today I also want to emphasize on that. Now when we look at this figure here, this is a quadrant with radius 2 cm, and we see that there's this rugby ball over here, or leaf, or whatever you want to call it, that's been cut out. Now if we are to draw a line across from here to here, well, this is not very, yeah, okay. If we are to draw a line from here to here, and we are to draw a line from here to here, can you see that this portion can be moved to fill up this gap over here, and this portion be moved to fill up this gap over here? What is this? This is circles quadrant. Okay. Yeah, Nexus, you got it. Vinay, you got it. Okay, so when you move it here already, you will see that in effect the shape is actually just like this. You have a quadrant with this portion being shaded. So you just want to find this shaded part. So to do this, what we will do is to find the area of the quadrant first. The area of the quadrant, it's going to have an area of 1/4 times radius 2, times pi 3.14 times radius 2 times radius 2. So this will give you 3.14. Okay, then the triangle itself that we want to get rid of, is going to have an area of half times 2 cm, and because this is a circle, a quadrant, a quarter circle, this will also be 2 cm. So its height will also be 2 cm. So this will give you 2 cm squared of an area. The shaded region then has to be 3.14 minus 2 to give you 1.14. So the answer will simply be 1.14 cm squared. So over here you can see that you need to combine certain techniques together to solve this problem. Here you need to draw this line to be able to see that you can fit this gap in. So once you have rearranged it in a way that you can use the known formula to calculate for your answer, then we can proceed to do whatever needs to be done. Okay, the top shaded part is a fillet. What do you mean by fillet? Then this will become a boomerang. Okay, very good everyone. Everyone got it. Okay, Edison, don't worry about it. If you're in P5, you will not have learned about circles at this point. But keep the idea in your mind. Oh, my head is blocking. Yeah, give me a while. Let me change back to this first. Sure, your face blocked a bit. Okay, wait. So if you got it, please spam the like button. Okay, how to tell that it fits? You can see that this, okay, there's one question from Jenny Lim. How do you tell that it fits? Okay, the reasoning is as follows. When you look at this semicircle here, and if you have drawn these two lines at 45 degrees, can you see that this entire thing becomes split into two, and this portion would have to be equal to, will have to be the same as this portion here. That's how you tell that it fits. Okay? Okay, let's move on to number 3. So this question is a rather unique one because it combines. Okay, let me open my head first. Yeah. Okay, so this question is rather unique because it combines the first question and the second question's ideas in order to be able to solve this. Okay, this composite shape is a combination of both examples 1 and 2. So you need to use the drawing of lines and the rearrangement of parts. And it is crucial for your child to understand the basic ideas first on simple regular shapes and then apply this to the more complex ones. So here's how we break this down. The figure is made up of 4 small circles of diameter 14 cm and a big circle of diameter 28 cm. So you can see that your 4 small circles over here, your 4 small circles over here is this one, this one, this one, and this one. Okay. And next up, you've got one big circle. The big circle is going to be this guy over here. So to find the area of the shaded part, round off your answer to the nearest whole number. By the way, when you do the markings for all this, one thing I need to emphasize. Okay, when marking out, use pencils for the diagrams, because once you use a pen and you do something wrong, right, even if you use a correction tape, okay, even if you use a correction tape, it's still not going to make the diagram perfect, and it's going to be quite hard to see how the original figure was. Okay, so you want to use pencils in case you make a mistake. Just assume that it's like Murphy's law, just assume that things can go wrong. So to deal with this, what we want to do is to split this up into 4 smaller squares. Draw out the outline of 4 smaller squares. Now to do this, we can draw a line. Wait, let me erase something first. Okay, let me draw a line from here to here, so that we can fit in these 2 gaps over here. Then let me draw a line from here to here as well, so that you can fit in these 2 gaps here and here. Then if I were to draw a line from here to here, this will go here and this will come here. And lastly, what is it? Okay, lastly, if I draw this part here, now you can see that wow, this one is so thick. These portions are going to come here. These portions are going to come here. These portions are going to come here. These portions are going to come here and here. So when we have done this already, you can see that essentially you would have a circle. After rearranging everything, you would have a circle. Okay, wait, let me just erase this off first. Okay, let me try to draw it to scale. Yeah, okay, more or less there. Okay. Yeah, it's gonna look something like this. Pardon me, my drawing has never been the best. Okay, so this part will be shaded, this part will be shaded, this part will be shaded, this part will be shaded. Okay, you want to rearrange it first, so that we can get this shape. Okay, then now the next question is, because this whole thing here, from here to here is 28 cm. That's all we know. From here to here, this gap is 28 cm. So this means to say that one of these radius, the radius itself has to be 14 cm. Correct? So now, to get this shaded region, all we have to do is to take the big circle area. This is going to have an area of pi 3.14. Wait. Oh yeah, sorry, I forgot to state it here. Take pi to be 22 out of 7. Okay, your big circle here will be pi 22 out of 7 times radius 14 times radius 14. So this will give you 616 cm squared. Then next up, to get the area of this square here. Okay, remember what I was mentioning just now? If the diagonal of the square is 28 cm, then essentially this would have to be 14 and this would have to be 14 cm as well. So essentially this is the square can be found by taking 2 copies of half times 28 cm times 14 cm, because this will be your perpendicular height here. So 28 times 14 will give you 392. So the shaded region itself is simply going to be 616 minus 392 to give you 224. So the answer here will be 224 cm squared. Okay, very good, Xing Ming Leong. Yeah, once you are able to determine what it is like, once you are able to rearrange it in a way that you can use known formula to compute, then it becomes easy. Find the square, minus it from the area of the circle. Yeah, subtract it from the area of the circle, correct. Radius of the small circle. No, the diameter of the small circle is 14 cm. Yeah. Okay. Now unicorn is because you should. Okay, you should pay attention. Okay, if you got it, please spam the like button so that I can move on. Okay. Hang on. Let me try to view something first. Okay, good. Now never mind, since it's a multiple of 28 and I didn't state it up front, let me just change it to 22 out of 7 for convenience. Okay. Now number 4, okay, thank you for your feedback. Number 4 is a question that came out in quite a recent paper, 2016 I believe. So in the figure below, rectangle ABCD has an area of 120 cm squared. And then they are given these dimensions of the shaded regions. And then they just tell you to find the area of the shaded part. Okay, how can this be done? Think about it first. How can this be done? You see that if you try to figure this out over here, you try to figure out this length, you cannot be found. You try to figure out this length here, it can't be found. You try to figure out this length over here, it can't be found. You try to figure out this length over here, it can't be found either. So the only information we are given is on the area. So while this is a paper 2 question 3, every mark is it's only worth 2 marks, but looking from a critical perspective, it could mean the difference between a grade. So every mark is precious nonetheless. So to deal with this, we can't really use the lengths. Okay, if you want to cut the figure, how would you do it? No, it's possible to solve and find the area of the shaded part. But this one is not that straightforward. So to deal with this, in fact, this also came out for NMOS question before. I don't remember the year, but I remember seeing it coming out in NMOS before. Okay, the whole idea here is this. Let's just trace out. If this is 2 cm, not enough info, right? Never mind. We just try to draw out the lines and figure out from there first. Okay, let me use a darker color. Yeah, okay, let me try orange. Okay, so you draw this line here. Okay, use a ruler because this one can get quite ugly. Then if this is 12 cm over here, we try to draw a line here as well. Then if this is 4 cm, we also draw this line across and try to figure out something along the way. Okay, so based on this, what can we do? Cut at the arrows or transfer. You want to cut your exam. Okay, wait. So based on this, right, there is one important theory that you need to always keep at the back of your mind. That is that if you have a rectangle and you split it across the diagonal. Why like that? Okay, you split it across the diagonal like this. It is going to be partitioned into two equal areas. Okay, just imagine your gardenia bread you fold into half with the you fold your gardenia bread into half through the diagonal. That's what I always did when I was a kid. Okay, then the next one is this rectangle over here that can be partitioned into two equal areas. The next one is this rectangle over here that can be partitioned into two equal areas. And the last one will be this square, and I use green, that can be partitioned into two equal areas. So you see that there is one little extra rectangle over here. Okay, this little extra rectangle has got an area. Okay, this wait, wrong tool. This little rectangle over here is going to have a length of 12 cm minus 4 cm. So this will be 8 cm. And over here, if this whole thing is 4 cm and this is 2 cm, then this would have to be 2 cm itself. Okay? So you all understand this so far? Okay, you don't understand, which part do you not understand? Yeah, they are actually half rectangles. Yes, Clarice, that's correct. No, Elaine, just try to stop saying I don't understand. Open up your mind and listen first. Okay? The battle is already lost if you go inside and say I don't understand, I give up. Okay, that's a very, it's your life but it's a very disempowering attitude to have. But ultimately it's your choice. Okay? So based on this whole thing, you see that they can be partitioned like this. You have W. Okay, let's call this triangle WW. Okay, then this, let's call this triangle X. Let's call this triangle Y. Let's call this triangle Z and triangle Z. So over here, you will see that, you will be able to see that your shaded region and your unshaded region both of them have the same elements. W plus X plus Y plus Z. W plus X plus Y plus Z. And on top of that, this shaded region has an additional rectangle area over here. So simply put, 8 cm times 2 cm will give you, okay, let me shift up my working first. 8 cm times 2 cm will give you 16 cm squared. So these two components, when you sum up all the areas, that will give you the area of the rectangle, which we are told is 120 cm squared. Okay? So if we put this up in a comparison model, then it becomes very clear on how we can go about to find the area of the shaded part. The area of the shaded part now must be 120. Okay, we want to add back this 16 over here. So when we add back a 16, okay, wait, let me make sure all my units are correct. 120 cm squared plus 16 cm squared. This will give you 136 cm squared. And this will give you 2 copies of the shaded region. So once we have that ready, all we have to do from here is to simply take 136 cm squared and divide this by 2. And doing so give us 68 cm squared. Okay, and this will be your answer. Okay, the area of the rectangle, as said, is 120 cm squared. No, the answer is not what you call yeah, the area is not 60 cm squared. It has to be 68 cm squared. Alright, there is a 16 cm squared here. Okay, if you got it, please spam the like button. Okay? Yeah. Yeah, boy. Okay. Thank you for your feedback. Why do you need to add the 16? Okay, if you look closely at this entire figure, the rectangle is made up of 2 copies of W, 2 copies of X, 2 copies of triangle Y, 2 copies of triangle Z. And also, after you have partitioned them inside this colorful rectangular arrangement, you will see that for the shaded region, it has an excess area of 8 cm by 2 cm, which is 16 cm squared. Everything else is the same between them, W, X, Y, and Z. So the shaded has an excess of 16. What that means is that in order for you to find the shaded alone, if this whole thing is 120 cm squared, then we want to add back 16 cm squared to the unshaded, so you have 2 copies of the shaded region. Then we divide that out by 2. Why not 120 divided by 2 plus 16? Because if you draw your comparison model, this comes back to comparison model. Okay, please go and review the idea first. That just wouldn't be logical. Okay, yeah, it's done. Okay, so thank you for sticking with me all the way through. Okay, and hopefully you liked it. So over here, we are commencing on the P6 model, heuristics approach to problem solving, happening on this Saturday, this weekend. Okay, for more details, you can head over to mathsheuristics.com/register. So let me just type out the registration link real quick. So this is for registering for the modular course on P6. This will be taught by Mr. Sani Tan, my boss and my mentor, okay, for the P6s. So the next one that I have for you is the Spatial Visualization Parents Webinar. So this will be happening this weekend from 2 p.m. to 5 p.m. 3 hours of hardcore teaching. Okay, I forgot to take something. Okay. The thing here is that we will be covering the contents of this book, this spatial visualization book that I was describing about earlier in the live session. Okay, we'll be covering all these techniques. Okay, and there will be a set of webinar notes that you will have. So let me just briefly describe what you'll be getting. First of all, you'll be getting the set of webinar notes, because I think if you personally, I find it, if you don't have these notes to follow, you're gonna fall asleep. The next one is on the spatial visualization ebook. Okay, then after that you will get the web videos access, mobile app access, and of course you also get 2 free trial lessons with 10OP. So this is for, I have to mention, this is for first time users who have never experienced the online lessons with 10OP before. So what is 10OP? 10OP is a online learning platform provider that has organized several ways, and we are always refining the process of delivering to make the online teaching and the online learning as close to real life as possible. Okay, we are always iterating on this. Okay, when is the 3-hour thing happening? On this weekend, Saturday or Sunday? Okay, you're welcome, Sandhya. Okay, so anyway, you're welcome everyone. So anyway, let me just type out, oh yeah, by the way, this whole thing only costs $25 net. Okay, so let me just type out the thing real quick. Hang on. Where is it? If you've attended it before, the concepts covered will be similar. So just view the replay. Oh yeah, one more thing, the replay is available. Okay. Okay, then for those of you who are sticking with me to the end, thank you for that. So as a little bonus, why is that? Okay, as a little bonus, if you want additional practice questions, here's where you can find them. Go to www.facebook.com/groups/maths heuristics. then you search for spatial visualization. Okay, using the tag function. Use the popular pose or tag function to do this. Then all the questions have been categorized over there. Okay. So if you want to access the archives, okay, the archives are over here. MUST-Heuristics.com/blog. Okay, to view all the other things that we've covered so far. Do you have webinar for P4? No, not at this point. Okay, thank you all for having me. Unicorn, I'll see you tomorrow. Okay. No, I'm not gonna watch. I'm not gonna watch Endgame. Personally, I never followed the whole Avengers thing. Okay, Karen, please write into. Okay, so if you already have the book, this is what I suggest. You write into enquiry at mathsheuristics.com and see what our management can do. Okay? No, I can assure you, if you spoil Endgame for other people, you're not going to have a very good life ahead. Yeah, so don't go and spoil the thing for other people. No, I heard about it, but I heard about it. Okay, you're welcome, Karen. Okay, bye-bye, Rebecca. Okay, any other questions? You're welcome, Karen. If there's no further questions, this is Kevin from Maths Heuristics signing off. See you all soon. Good night.